Okay, yesterday we talked about what is a triangle. Well, today we're going to talk about a triangle's angles and some interesting things that happen with a triangle's angles. The first thing about a triangle's angles, it's kind of hard to say, triangle's angles. If I'm not careful, I might say something naughty or whatever. But anyway, we learned this yesterday, but today we're just going to kind of informally prove it. But the sum of the angles of any triangle is equal to what? How many degrees? 180. We call that the triangle angle sum. Triangle angle sum theorem. It says the sum of all three angles of any triangle is equal to 180 degrees. There can never be more than one obtuse or right angle in any triangle because their sum would be more than 180 degrees. And then what I've got here is I'm going to kind of do what's called in math a proof. You won't ever have to do a proof, but basically what I'm doing here is I'm showing you why we can say that all three angles of a triangle add up to equal 180. Well, last week we learned about parallel lines cut by a transversal, like so. If I say this AC is parallel, or I construct this line segment right, or this line right here that's parallel to that shows that and that parallel, I've got these two transversals. So I'm going to kind of extend my transversals just so we can see like we did yesterday. Okay? So these are two transversals. And if we did our circle box thing on these transversals, we would find out that this angle 1 right here and this angle right here would be congruent to each other. They would be alternate interior angles. So we would say that this angle and this angle are congruent. Well, the same thing happens over here. This angle 3 right here would probably be a box, and this angle right here of the triangle are congruent. So this and this are equal, this and this are equal. 1, 2, and 3 together form a straight line. So how many degrees does a straight line have? 180. So since 1, 2, and 3 add up to equal 180, we can substitute this 1 for this right here. That right there would be this angle, and we could substitute this 3 right here. So 1, 2, and 3 would add up to equal 180 degrees as well. Okay? Now that's kind of an informal proof of that. It's not really formal, but that's just kind of why we can say that triangles have 180 degrees, because the angles right here form a straight line. Okay? So now we need to talk about the third angles of a triangle. Let's say I've got two triangles. So this is what we call the third angles of a triangle. Third angles of a triangle. It says if two angles of one triangle are congruent to two angles of another triangle, then the third angle is also congruent. Okay? Now let me show you with numbers here, okay? Let me show you with numbers. If I draw a triangle like so, and then I draw another triangle, and we'll say this is 70 degrees, and we'll say this is 80 degrees. If I draw another triangle with the same angle measurements, that's 70 degrees right there, and that's 80 degrees, well, what do all three angles have to add up to equal? 180. So we would do 180 minus 80 minus 70, and that gives us 30 degrees right there, doesn't it? Well, these are the same as well, right? 180 minus 80 minus 70 is also 30 degrees. So this missing angle right here has to be congruent to that missing angle right here, because these two angles are equal and these two angles are equal. Okay? So that's basically what the third angles of a triangle theorem says. If I have two triangles, I'll draw a different triangle here. if this angle is congruent to this angle, and this angle is congruent to this angle, then it can be said that this angle and this angle must also be congruent. Okay? That's what the third angles of a triangle theorem says. Alright? So any questions about it? Alright, next up. Exterior angles. Exterior angles are angles on the outside of a triangle that form a linear pair with interior angles of a triangle. Okay, and I'll show you an example other than this one here in just a second. But the angles that are not adjacent to the exterior angles are called remote interior angles. Remote interior angles. So we've got exterior angles and we've got remote interior angles. So in this picture, if I extend this side of my triangle out and this angle makes a linear pair with angle 1 of the triangle, then angle 4 is an exterior angle. So angle 4 is an exterior angle. That makes the two angles away from it, angle 2 and angle 3, remote interior angles. Okay? Remote interior angles. Now we have to be careful here. We've got to be careful because not every angle that's on the outside of a triangle would be an exterior angle. And here's what I mean. Let's say I draw a triangle on this piece of paper right here. And I extend that side out right there, okay? But let's say I also extend this side right here out past it. Now here's my angle of the triangle right here. We'll call this angle 1 right there. Okay? We'll call this angle 2, this angle 3, and this angle 4. Are all of these exterior angles, are all the angles on the outside, 2, 3, and 4, are they all exterior angles? No, and here's why. Everybody see how 2, if I cover this up, 2 and 1 make a linear pair, don't they? So that means that 2 is an exterior. Angle 2 is an exterior angle. Okay? Angle 2 is an exterior angle. Angle 3, however, doesn't make a linear pair with the interior angle 1, does it? So angle 3 is not. Angle 3 is not exterior. Angle 3 is not exterior. But angle 4 makes a linear pair with the inside angle of the triangle, so angle 4 is an exterior angle. Okay? So does everybody see the difference and see why 3 is not an exterior angle? Because it doesn't make a linear pair with angle 1. Okay? Now 2 and 4 make a linear pair with 1, but 3 doesn't. Okay? Now these angles over here, 5 and 6, are my remote interior angles. Okay? 5 and 6 are my remote interior angles. So, let me ask you a question. All right, I'm going to cover this up for just a second. We're going to do a little mini proof right now. What do angles 1 and 2 have to add up to equal since it's a linear pair? 180. So angle 1 plus angle 2 has to equal 180 because it's a linear pair. Okay? What do angles 1, 5, and 6 have to add up to equal? 180, right? Because 3 angles of a triangle add up to equal 180. So angle 1 plus angle 5 plus angle 6 equals 180. And that's triangle angle sum. Okay? Now let me ask you a question. If I have 9 $20 bills in my pocket, okay, and you have 18 $10 bills in your pocket, who has more money? Both the same amount, right? They're both $180. Now, you guys may have more bills than I do, but amount-wise, they're both 180, right? So 180 is equal to 180 any time, isn't it? So if this is 180 and this is 180, it should go that this part right here, by substitution, angle 1 plus angle 2 has to equal angle 1 plus angle 5 plus angle 6 equal this substitution, okay? Because 180 is equal to 180. Well, what angle do both sides of my equal sign have in common? What angle does the left-hand side of my equal sign and the right-hand side equal sign? Angle 1, right? So I can subtract angle 1 from both sides, where those would cancel, and I'm just left with angle 2 is equal to angle 5 plus angle 6. Which brings us to our next vocabulary, the exterior angles theorem. Exterior angles theorem. Exterior angles theorem. And it says the measure of any exterior angle is equal to its 2 remote interior angles. Now, the other part of this, the exterior angle, is always greater than any one of its remote interior angles. Okay? So essentially what I'm saying here is this angle 4 is equal to these 2 remote interior angles, 2 and 3, angle 2 plus angle 3 together. Okay? Angle 4 is equal to angle 2 plus angle 3. And I'm also saying that angle 4 is bigger than angle 2. And I'm also saying angle 4 is bigger than angle 3. Alright? That's what the exterior angles theorem says. The exterior angle is equal to this angle plus this angle. Okay? Any questions? Alright, let's go on to the next page when you got all that written down. Okay? When you got it written down. Okay. So let's start off easy. I'm going to show you how you can do this in your calculator, even for the easy equations, but I'm going to do it mainly so you can do it for the hard equations, okay? Alright, so we're going to find the value of x in this triangle. Well, what do all 3 angles of that triangle have to add up to equal? 180. So x plus 24 plus 65 equals 180. Okay? Now, I know that you know to solve that where you're going to add 24 and 65 together and then subtract that result from 180. I know that you know that, okay? That's pretty simple. You just got to do 180 minus 65 minus 24 to get the answer. But sometimes they're going to be a little bit harder. Like the next one's going to be a little bit harder. So I'm going to make sure we know how to put this in the calculator, okay? So I'm going to put a little dotted line between my equal sign. And then I'm going to go to numeric solver. I'm going to go math. I'm going to arrow up to numeric solver, and here's what I'm going to put in. The left-hand side of my equal sign will be my E1. The right-hand side of my equal sign will be E2. Okay? So I'm going to put X plus 24 plus 65 on the left-hand side. Arrow down and clear that out, and put 180 on in the E2 box. Okay? Now be careful. Everybody see the OK button? Once you hit it, that doesn't automatically solve it. 65 is not my answer. To make sure that you have the correct answer, underneath this bound, it needs to say E1 minus E2 equals 0. So I'm going to hit solve again, and boom, X equals 91. So there's my answer here. X equals 91. Okay? X equals 91. Yes, sir. Can you wait till after notes, or is it? Okay, go. Yeah, go. Usually I ask if you can wait till after notes, but if you can't, I understand. All right, any questions? Now, of course, to get out of that, you hit second quit. Now, of course, you can do 180 minus 65 minus, not 34, 24, and you get the exact same answer, okay? I would expect you all to probably do that on this problem. But the next problem, you might want to use your equation solver, your numeric solver, because we've got 2y, so I'm going to say that 2y plus this y plus 15, I'm not even going to put the parentheses around it. I'm just going to put y plus 15 plus 63 equals 180 degrees. Now, if you want to, you can solve it by combining the 2y and the 1y and getting 3y, and then 15 plus 63 gives you 78, and then solve it that way if you want to. I'm okay with that, but just to save yourself a little bit of time, I'm going to draw a line between my equal sign. The left-hand side will be E1. The right-hand side will be E2. Okay? So I'm going to hit Math. I'm going to go up to Numeric Solver, which would be C. Now, instead of Y, though, the X, this says X, T, theta, and N. I'm just going to change the Y to X, but in my answer, I'll just leave it Y, okay? So I'll say 2X plus X plus 15 plus 63. That's my E1, okay? Instead of Y, though, I'm using X. I'm not sure if you can use Y or not. You can get a Y by doing alpha Y, but I don't know if it'll do it or not. I'll have to check and see. Arrow down, I've already got 180 in my calculator, so I'm going to leave that alone. Then I'm going to hit graph. Is 91 my answer, the same one as I got before? No, you have to hit graph again, and what does it have to say underneath that to make sure that you have the correct answer? E1 minus E2 equals 0. So my Y is equal to 34. Okay? 34. Any questions? Now, if I wanted to find those other missing angles, this angle right here would be 2 times 34, or 68. This angle would be 34 plus 15, which would be 44, 49. So this angle, so I have a 63, 68, and 49 triangle. Okay? If you want to check it, we can add those numbers up. 68 plus 49 plus 63, bam, I get 180. Okay? Does that make sense? All right. Next up, any questions on that? Is everybody cool on how to use the numeric solver in your calculator?
Can you explain one more time how to get to it?
All right, to get there, you're going to hit Math. Everybody, you're going to hit Math, and then I hit the arrow up key right there, and then it'll say C, numeric solver, and then click Enter. And that brings your E1 and E2 up. Okay? Got it? All right. So let's look at this. What do we know to be true about the value of M and N? Well, let's find out what M and N are. Now, I'm not going to use my numeric solver for this because I'm going to assume you know how to find it if you need it. Okay? But I'm going to say that M is 180 minus what? 50 minus 30, okay? So I'm going to go to my calculator, do 180 minus 50 minus 30. It should get 100. Good. So M is 100 degrees. Now let's do the same thing for N. N is 180 minus 58 minus, good deal, Pickles. So 180 minus 58 minus 28, I get 94. Now those two, is M and N equal to each other? Are M and N equal to each other? No. But we do know that M is bigger or greater than N or less than N. M is greater than N. M is greater than N. So that's what we know to be true. M is greater than N. Okay? That's it. That's all you got to do. You would pick M is greater than N. Okay? Any questions? Alright, this one involves your exterior angles theorem. Okay? Now I probably will, I don't really have to, but I'm going to use the equation solver for this because I need to know that this 100 is equal to, 110 degrees is equal to this 45 degrees plus this x degrees. I'm going to add those two numbers. Those are your remote exterior angles. 45 and x are your remote exterior angles. 110 is your exterior angle. I said that wrong, guys. The 45 and the x are remote interior angles. The 110 is your exterior angle. Okay? Your exterior is equal to your remote interiors. Now, you guys know you would probably subtract 45 from that side, and you would be correct, but I'm going to show you again how to get to and do your numeric solver. So we're going to hit Math. We're going to hit Up and do numeric solver. We're going to clear that out, and E1 will be 110. E2 will be 45 plus X. Okay? Click Enter. Is 34 my answer? No, you have to hit Graph again. It might be, but it's not. X is 65. Okay? X is equal to 65. And if I take 65 and 45, I better get 110. Okay? And I do. Any questions on that one? Alright, last one. Last one. Now this one, we don't have any of the interior angles. But that angle right there is a linear pair, or has a linear pair there. So this angle has to be 180 minus 135. So I get my handy-dandy calculator here, 180 minus 135, I get 45 degrees. So that angle is 45 degrees. So I'll put a 45 right there. This angle right here is 180 minus 156 degrees. 180 minus 156 is 24. So this is 24 degrees. Alright? And then all you have left to do here is say that M is equal to the sum of the two remote interior angles, 45 plus 24, and I'll just do that one in my head, because 5 plus 4 is 9, so M equals 69. And that's it. Okay? Any questions?
Number 4.
Uh-huh.
I did it differently. For 110 is like the linear curve with the angle next to it.
Uh-huh.
I just put 70 because 7 plus 1 is 180.
Yep.
And then I can do 45 minus 180 to get it.
That's what we did with the proof, didn't we?
Yeah.
Because the proof, we'd said that this and this has to equal 180. And then we said, well, if this and this is 180, and this and this equal 180. I mean, what you did is perfectly fine. Everybody hear what he did? It's perfectly fine. I'm just saving you that extra step, okay? This just saves you an extra step, because instead of saying, well, 180 minus 110 is 70, and then 180 minus 70 minus 45 is X, that's two or three steps right there. I'm just saying, well, how about doing 110 minus 45 and getting 65, okay? So you're correct. You can do that, okay? You can do that. And you can do the same thing here. You can say, well, this is 180 minus 45 minus 24 and get whatever this is, and then do 180 minus this, and you'll still get 69, okay?
That makes sense to me.
Yeah, you do it that way. That's fine with me. All right, glad you enjoyed it, guys. All right, I'm going to stop this real quick.